the notes for AP Calculus on the topic of the squeeze theorem. So the squeeze theorem, like the name suggests here, is when you've got two different and another third function that's squeezed between it. In this case, f of x is the one that's squeezed between g of x and h of x, where g of x is less than or equal to f of x, which is less than or equal to h of x. For all x not including c, so it doesn't have to include c. And c here represents the specific x value right here in the graph. And we've got g of x is the least of these, so this is the graph of g of x here. H of x is the greatest of these, right here. And f of x is the one that's squeezed between the two. So what the squeeze theorem is guaranteeing that if, there goes an if and an then part, so the if part of the statement, if this is true, that f of x is always between g of x and h of x, and the second part of this is the limit as x approaches h of x equals the limit as x approaches c of g of x, and that equals some limit L. The limits are equal to each other, so L is represented by the y value right here. So you can see on this graph, h of x does stay greater than or equal to g of x the whole way, and f of x stays between them the whole way. But right here at this point, they have the same limit. So from the left and the right, h of x and g of x are approaching the same thing. So what it's saying, if that happens, then what this guarantees, here's the then part of the statement, then the limit as x approaches c of f of x, the one that's squeezed between them, would have to equal the same limit, basically. Because as we follow f of x along, it's between g of x and h of x, is greater than or equal to g of x, less than or equal to h of x. And then since these have the same limit, there's nowhere else but f of x to go, but it gets squeezed right there. So it has to have the same limit as f, h, and g do as well. And notice here it's drawn as a closed circle, but it actually could be an open circle as well. And that would not, this was open right here, that wouldn't affect the limits at all. This would still be true. And that's why it says x doesn't have to equal c. So this inequality might not hold true at c because they might be undefined there or not exist at c, but this squeeze theorem would still hold true, so it doesn't have to apply right there. Although it could be a close point too. Okay, so let's see how this works with some specific examples. So here we've got h and g. Here's h of x, and here's g of x, and here's h of x here, given the two equations. And then here's where it says g of x is less than or equal to f of x, which is less than or equal to h of x. And in this case, our c value is right here. X equals negative, x is approaching negative 1 of f of x. And notice, this is true, negative 1 is in this interval. So that means it doesn't always have to apply everywhere, as long as the c value that x is approaching is, this inequality holds true on that interval that includes that. And in this case it does. Negative 1 is between negative 2 and 0. So what we have to do is figure out what the limits are of both g of x and h of x. Notice we don't have the function f of x, so that's using g and h is how we're going to go about figuring it out. So the limit as x approaches negative 1 of g of x is the sine, careful there's a lot of parentheses here, pi over 2, negative 1 plus 2 plus 4. And notice that becomes negative 1 plus 2 is 1 times pi over 2, so it becomes sine of pi over 2 plus 4. And sine of pi over 2, if we draw that over here real quick, pi over 2 is right at the top. Sine, remember, these points is the y-coordinate, so sine of pi over 2 is 1. So that becomes 1 plus 4 gives you 5. Alright, so now let's compare that limit, 5, with the limit as x approaches negative 1 of h of x. And again, first thing you try is direct substitution. So if you substitute negative 1 there, you have negative 1/4 negative 1 cubed minus 3 halves, negative 1 squared minus 9 fourths times negative 1 plus 4. So negative 1 cubed is negative 1 times negative 1 fourth, makes that a positive 1 fourth. Negative 1 squared is 1 times negative 3 halves, stays negative 3 halves. Negative 1 times negative 9 fourths is positive 9 fourths, and then plus 4. And then if you just get a common denominator of 4, you've got 1 fourth minus 6 fourths plus 9 fourths. Multiply 4 by 4 over 4 is the same as 16 fourths. So if we add these up here, we get 16 fourths, 9 and 1 is 10, so that's 26 fourths minus 6 fourths is 20 fourths, but 20 fourths is the same as 5. So here, notice they are exactly equal, and f of x is stuck between them. So our limit, since these are the same, would also, for the limit as x approaches 1 of f of x, the one in between would also have to be 5. It gets squeezed between those. All right, let's take a look at the next one here. So here g of x and h of x are given again. And g of x doesn't have to be the one that's the least of h of x could be. It's just really arbitrary which one is which. Okay. And again, this is for f of x is between there on the interval from 0 to 2. And the important thing is that's true when x is approaching 1. So it does work because we can try to use the squeeze term because 1 is an interval from 0 to 2. We know this inequality is true. So let's again find the limit as x approaches 1 this time of g of x. That'd be 2 plus the natural log of 1. And remember, natural log of 1, natural log is log base e, so it's saying e to what exponent equals 1, and you can see that's 0, so that's 2 plus 0 gives us 2. Now let's find the limit as x approaches 1 of h of x. So for this one, again, substitute 1. And get cosine of 0 plus 3. Well, cosine of 0, 0 is right here underneath the circle, and cosine is the x-coordinate, so that's 1 plus 3 gives you 4. So notice this time they're not the same. So it's not going to look like our graph over here. There's going to be a gap here between them. But the key is f of x is still squeezed between them, just not quite as tight of a squeeze here, I guess you could say. So what we really know about this limit here, it still tells us some information. It tells us it's somewhere between 2 and 4. So we know 2 is less than or equal to the limit as x approaches 1 of f of x, and that's less than or equal to 4. So somewhere between 2 and 4. So you might think, oh, well, that means the answer is 3. Well, it could be 3, or it could be 2, or it could be 4. Actually, it could be any of these 3, because it could equal, because remember, it's less than or equal to, so it could be any of those. And because it asks what is the limit, here you'd say, well, you don't know for sure. You just know it's somewhere between 2 and 4, so you cannot determine it exactly. So the answer here would be D. All right, let's take a look at one more that's worded a little differently. So again, we've got two functions, g of x and h of x. Notice this time it just happens to be flipped around. So h of x is the one that's less than. G of x is the one that's greater than f of x, but f of x is still in between them. But here's the difference in the wording. Notice these first two said, what is the limit? Whereas this one says, which of the following could the limit equal? So that's a big difference in how it's worded. Not what does it equal, what could it equal? So again, here's our c value. X is approaching pi, and notice pi is between 3 and 4. So we can apply to answer the squeeze theorem here. So let's find our limit. Again, it doesn't matter which one you do first. The limit as x approaches pi of g of x. So that'd be 3 minus the cosine of pi. Cosine of pi. Draw that over here. Pi is right here. And cosine, remember, is the x-coordinate. That would be negative 1 right there. So that'd be 3 minus negative 1. 3 plus 1 gives you 1. So let's compare that with the limit as x approaches pi of h of x. So it'd be 1 plus e of pi minus pi. That just gives you an exponent of 0. E to the 0 is just 1, so you get 1 plus 1, which is 2. So it's similar to what happened in the last one, where we got 2 and 4. However, the big difference here is the way it's worked. Which of the following could this limit equal? So if we use the same inequality, we know, okay, this limit has to be between 2 and 4. 2 is less than or equal to the limit as x approaches pi of f of x, which is less than or equal to 4. Okay. Has to be somewhere between 2 and 4. Which one could it equal? Well, 1 is too small. 5, 7, and 9 are too big. The one it could equal, in this case, is 3. We don't know for sure it equals 3, but it could. And that's what it asks for. So just pay close attention to the wording. Is it asking for what the limit is exactly, or is it saying which value could the limit equal? And that concludes the notes for AP Calculus on the topic of the squeeze theorem.